Today's video is part 1 to our plate boundary series. We will be reviewing the layers of the Earth in this video and the 2 types of crust. In the following 3 videos, we will look at divergent boundaries, convergent boundaries, and transform plate boundaries. So let's start by looking at the lithospheric plates. Remember, the lithosphere is the crust in the rigid mantle, and you can find that information on page 10 of your reference table. But if we look at this very simple diagram of the Earth, the outside layer would be the crust, further down would be the mantle, and the Earth's interior is the core. Now when we look at page 10 of our reference table, we know that there are many more layers within that, especially in the mantle, and there's 2 parts of the core. But this is just a very simple diagram that we're going to look at here. Within this, you should know that as you move deeper into the Earth's interior, it gets a lot warmer, so the core is very hot. And then we also want to talk about what's going on in the mantle. Alfred Wegener couldn't figure out that convection currents were going on in the mantle, but we know that this is probably true today. Why is convection happening? Well, we have hot, molten material in the core. We know that very hot or warm things are going to rise up. As they get closer to the crust, they will cool down, and we know that cool things will then sink due to their difference in density. So, let's take a look here. If we had this hot magma rising up, we then had it cooling down, it would then sink, and then as it gets closest to the core, it's going to warm back up again, and continuing through this cycle. So you can see here, there's the convection current in your mantle. This will continue all the way around the planet. And this is why we're seeing that our plates are moving everywhere around the planet due to this convection current all the way around inside of the mantle. So I could finish drawing them all the way around, but that's what's going on inside of our mantle. I want to draw your attention to these very specific areas. You can see that there are many different plates, and we've looked at that on page 5 of our reference table, but there's these breaks in the plates of these plate boundaries. At these plate boundaries, we either see that the crust is going to separate, it's going to come together, or it's going to move to side. The area that I've circled right here, you would see that the plates are moving apart due to that rising magma. So then as it rises up, the convection current pulls it apart. In a different area, like this one right next to it, you can see that the plates are moving together. This would be a convergent boundary. We have the magma pulling those plates together. They collide, one will probably sink or subduct, and then go back down towards the core. Okay? So all around the planet, we're going to see these plates meeting due to these different pieces of convection. Just as a review, we want to talk about the 2 types of crust. Underneath the ocean, we have oceanic crust. Oceanic crust, if we look at page 10, is made of basalt. Basalt is more dense than granite for our continental crust, so let's make sure we write that here. And I'll show you on our reference table where we can find this. If we look at page 10 of our reference table, we're looking right here, and this is 3.0 basaltic oceanic crust. Even though it is more dense, it is much thinner than the continental crust. It's only about 3 to 4 miles, and instead of using the word thick, I'm going to use the word thin because it is the thinnest layer of the Earth. Then we have our continental crust, which we can see down here where we've circled before, is made of granite, and it is less dense than the oceanic crust. This is a little bit thicker, but we're still going to call it thin. It's about 20 to 30 miles. And the reason we're going to call that thin is because when we talk about the mantle or the core, they're much thicker than the crust. So the crust is the thinnest layer that we have. So if you ever need to know anything about the lithosphere, where convection is occurring, densities, temperature, pressure, remember you're going to go to page 10 of your reference table.